Right.
All right, I think we're good. Yep.
Cool. Yeah, I thought we have some. This is created in the dev communication calendar. Maybe just I'm not the owner of that one. Maybe.
I think I own this one now, but the problem is I don't have the right account. I'll
Okay.
start paying for
No
it,
worries.
whatever. I feel like this comes up so often.
Or you can give me permission so that I can do that next time. All right. Then let's go in for let's keep going for this time. Thanks for everyone for joining this meeting. So just a little bit of recap from the last few meetings. We are discussing SQL UDF. A few topics we discussed last a few times is the overloading. How do we handle overloading and permissions? And one of the topic is the I think I putting one of my doc is I think Ryan mentioned this potential issue is in a malicious user can potentially suddenly change the behavior if we allowed any people to just create new overloading for one particular UDF. So this is one thing we discussed, and there's some discussion last time also around how do we handle permissions, how do we organize multiple overloads in the metadata. While the consensus we got is I think we try to put multiple overloads into one single metadata.json file for that UDF. So we can still use UDF name for listing UDF and to as an identifier to identify this particular UDF. At the same time, there's multiple overloads with different signatures for sure, like in terms of the like type of the parameters and a number of parameters. And we put them within the same metadata.json file so that they could be, every time there's one engine try to load them, we return all of them by default. I think this is what we discussed. We return all these signature overloaded to the engine side. And then engine decide which one to pick. And normally we expect engine to behave, say, okay, you definitely you pick if you can pick exactly the same match with your parameter, you pick that one. But if you cannot, for example, you want to do the type promotion, just to try the best to pick the closest one. Uh, this is kind of from the spec side, we make certain recommendation to the engine, and the engine should do this thing to make sure it works well. And I think this meeting we might discuss because previously we don't think about the put multiple overloads within the same metadata.json. So if you look at the JSON doc, the doc is still describe the one single overload within the metadata.json file. So we need a little bit of structure change for that one. I think this meeting maybe we can discuss a little bit about that one. And another a few topics I want to discuss is, for example, every time we try to update the UDF, I think we may not allow you to update the return type, which seems a little weird because if you update the return type, it will change a lot of stuff, especially when you go to the overloads, multiple overloads. Signature, I think it's probably something we should not allow you to update as well. You can definitely create this new signature. Of course, like there's a few difference between them because right now we put multiple overloads within one metadata file. So that means update every time you create new signature, new overloads, you actually update that particular overloads. And you update these metadata file. So that's something we have to think through. I think we just to make sure user doesn't fall into some traps.
I'm not sure I caught all of what you were laying out there. It sounds like because the doc hasn't been updated yet to reflect the latest that we've talked about, there are just some uncertainties in how the pieces like signatures, overloads, versions, and stuff like that fit together. Is that a fair?
Yeah. I think that's fair.
Okay, yeah.
So I have
To me,
this.
it seems like a return type is going to be, now I could be crazy here, but I thought the return type would be tied to the signature.
If we
I
type
might be missing something, but if I have like and maybe this isn't a case we want to support, but I was thinking of something like add, right? If I have an add function with, long and long, I expect it to return a long. If I have an add function with float and float, I expect it to return a float. It would be a little weird if I had add, long, long, and everything had to return a double because my widest type were double. So similarly, like if you think about some of the Iceberg transforms, those don't fit in this. So like truncate, where a decimal truncated returns a decimal, an int truncated returns an int, etc. There are some pretty simple functions that I think you would want to manage as overloads of the same thing that don't have a uniform return type across all of them.
Is there any reason that we wouldn't support variable return types based on signature?
Yeah, I think one of the reasons I'm trying to think about it is because if each different signature is kind of gonna have their own return type, then every time you create new signature, you have to specify a new one. And then for ending stage, okay, maybe that's fine. Ending can just still peek into each individual overloading and check their signature and a return type so that they can still make the right decision if they need it.
Yeah, it seems to me that oh, sorry, go ahead, Russell.
I was going to say, yeah, engine should look for call site matching first. Like it needs to make sure the parameters of the function match. And then after that, it can then look at the return type to see if it can use the return type in other stuff. But the engine doesn't need to actually look for a function with a specific return type because it really can't. Because it doesn't actually know based on the function parameterization like what the return type should be.
I agree. There should be one and only one function that well, sorry, I guess you could have multiple functions that fit the parameters, but right, like I could have again add int and long long, and I can apply either int or long long. That would determine the return type, right? So if I add an int and a long, I'm going to use the long version and get a long back. I don't think that you would want to choose a function based on the return type, but at the same time, I don't think it would matter if you did. That I think is delegated to engines, because what we're saying is we're going to give you all the versions and signatures of the function we know. I consider the return type to be part of the signature probably, and like you can insert and use whichever function suits you. I don't think that the protocol or objects need to actually like dictate that.
Yeah, so the only thing I would say, like in consideration of this, is like obviously you can't have the same signature with two different return types as different signatures. So signature is like return type is part of the signature, but it's the parameters define overloading, right?
Yes.
So you have to have a distinct set of parameters.
I'm trying to think of any languages or compilers I know that would like everything I know is basically like compilers look for the most fit in parameter space, like the most fit that is still covariant, like with what they're allowed to do. And I don't think any of them would like choose one that is higher in a hierarchy just because your return type was different.
Yeah, covariance and contravariance really only comes into play with inheritance, right? So you would only have that scenario with covariance or contravariance with overloaded method with the same signature that is returning either a subclass or a superclass of that type, and that's allowed or disallowed depending on the language.
I think you could look at like int and long as, you know, because you can cast between them, you could look at that as like a subclass relationship, right? Where int is a subclass of long. So like you might be able to squint, but to Russell's point, like I agree. I don't know of any language that will choose a different function based on the return type. It matches based on the actual, you know, type returned.
Yeah, I'm actually did some
Sure.
search on multiple engines. I think there's no support for the return types overloads. It's mainly focused on the signature. I think one of the reason most engine does not support return type is still it become ambiguous when you have different return types. You don't know which one to pick.
But that can only be the case if you have. So I guess the cases I can think of where that would be a problem would be if you have parameters that and the inputs to the parameters have to be widened, right? And there's a question as to how do we widen and which set of parameters do we widen to if there's multiple options. But I'm not sure that I can. Like, I guess you could have a function that takes an int and a long, and you could have another function, another representation that takes a long and an int, and you pass in two ints. Which one do I use? And if they had different return types, you could get different results. But like now we're getting into kind of weird scenarios, and assuming that you are allowing widening within the parameterization.
I think though that this is not an area where the spec needs to take a stand, because what we're talking about here is how to communicate to an engine the functions and signatures that exist, and it is up to the engine to choose which one to use. If an engine wanted to choose the one that, you know, does integer division because you're expecting a long, I don't really have a problem with that. I think it's weird. I wouldn't build an engine that way, but I don't have a problem with anyone who does.
Yeah, I would agree with that. And in those kind of scenarios, especially like it's on the engine to determine if there's ambiguity or to define a specific set of rules of how they will, you know, like widen or cast or whatever within the invocation of a function.
Yeah, I think that makes sense. I agree with everyone here.
So I think what we're saying is uniqueness within the signature space is based on parameters, not on the, like, if we consider the return type part of the signature, that is excluded from determining whether it's a unique representation.
I don't. Okay, well, I guess we do need to define what can be unique. And I think we don't want to force people into choosing based on return type, because that is unexpected behavior. So I would say, yes, a signature is the arguments to the function, and then the function has a separate return type that defines what it outputs. But uniqueness of an overload is determined by the arguments to the function and not the arguments plus the return type.
Yeah. So I think we can move forward a little bit. Let's go back to my previous question. Are we allowed the user to change the return type of the one overloading?
I think that one thing that I'm thinking through is, like, we have examples of signatures where the, like I think Snowflake works this way, where you do create function foo with argument returns thing, right? And you can model this as, drop function with that signature and add function with that signature. So with different return types. So I don't really see a strong argument for not allowing the return type to change, right? It just changes. If you can do it in multiple steps, you can effectively do it in a single step.
Yeah, I think Snowflake does what Snowflake does a little bit further because it can actually validate your the body parts, the representation parts with your return types to validate if that's compatible type. Here we cannot have things because we have a multiple dialects representation within that body. Then maybe we like each individual engine can still do the validation by check the return type with the last statements of that body to see if that's compatible. That's maybe just the engine side behavior. We allow engine to do so. We don't have to put them in the spec. That's my point.
Well, in that case, okay, so I think that's a different question.
Yeah, it's a different
whether
question,
we
yeah.
can, say replace function and change the return type with a different body, assuming the whole thing is consistent with itself. I think that's a different question than how do we handle the return type. What you were getting at in the last little bit, it sounds like, is do we trust the return type to be what is actually produced by the expression, right? And if so, what are the requirements for actually making sure that we all agree this expression returns this type? Or does it mean that if you get that expression, you should you should add a cast to the type if it doesn't already exist, right? If it's the wrong type, if I have int plus int equals int, but I say that this thing returns a long, should I insert a cast? And the third option, right, like, so we could have full validation, it's required to match or we blow up. We could have insert a cast if necessary and you get what you get. Or we could have, the last option would just be we don't specify the return type. But I think that we do want to specify the return type as a hint, at least, because it's part of the SQL standard. So I think we want to assume that you've done some form of validation here.
Yeah, my point is engine should do that. Should we? I think we may not put that into the stack. So because each multiple like dialects, like for example, Spark, when it's it updates its own representations. It did the validation against the return type versus last statements of that body.
What if we made this optional? The return type, if present, should be something that you have validated. And that gives you a check that the expression returns the same thing across engines. Versus if you're just creating a function with a blob of SQL, it can be null or not present, and the engine can determine what the return type is. Because I don't like the idea of, like defining this and then having problems simply because like you guessed the wrong return type or something. I don't know.
I guess I don't fully understand why that. I mean, in any of these cases, if you're defining a UDF, you're probably having an engine parse it and validate the UDF itself, right? So it's going to resolve a return type at that point. So we know, and unless like we expect that engines are going to have different Iceberg representations of return types for different statements, we should actually know what that return type is. And I feel more comfortable defining that explicitly so you don't just allow for random, because like one engine may look at that and say, hey, if no type defined, I'll just cast it to whatever I want or whatever it's being, wherever the context is that it's being used. And you may end up getting different behaviors. And I'm not sure that I'm convinced that there's a good scenario where we have to actually leave it undefined.
So I buy that you kind of want this as a check, right? In the case where one engine parses an expression and then says, hey, this produced an int, you don't want another engine parsing that expression, producing a long, and then like having that chain reaction through a query or a double or anything like that. So I think if the return type is there, you should validate that you get the same return type at a minimum. The question is, should we allow the case where the return type is left to the receiving engine to determine?
So here's
yeah, go ahead.
Here's my kind of strong opinion on this is I'm thinking about how this goes forward in data protection rules. Do we really want to have the ability to have undetermined UDF return types in like a series of expressions that we're building out if we're building like a data protection rule? So like if I'm building an expression that has UDF as part of it, one side is well defined and the other we're like at runtime you'll figure out what this is going to be.
Well, I think the question there, though, is like, it's still the same question because like if you're building one out for data protection, you include the return type, right? That doesn't prevent you from doing that. Are we specifying that it's required because of data protection?
So another thing here that I think we should think through, even though it's not in scope right now, is what happens when we add Python? What happens when we add, I don't know, JavaScript? Like, if we have additional things that maybe the engine treats as more opaque things, in those cases, do we want to insert a cast and expect this thing to be there? Do we want to, I mean, we certainly need a way at runtime to determine the output type. Maybe that means we just always require a type and say like, hey, if it's a SQL expression, the type must match. That gives us the maximum like predictability for cases where this is in security expressions and all that. But I could see getting it wrong when it comes to a dynamically typed language.
Well, but it's always easier to make a required field optional.
And I think that is probably a very good argument for doing it. Let's just make it required. We can define in a later version what happens if it's optional, and we can take care of it that way. But until then, you should parse the expression and get the exact same return type. If not, it's invalid.
I'm good with that.
Yeah,
that makes the most sense to me.
I feel more comfortable with that than having an optional out the bat. I just feel like we would be setting ourselves up for like 2 UDFs in a row. What do they actually do? Like, you could have different behaviors in different engines if they decide to interpret the return types differently, and then the next calling UDF is then different because it got a different UDF from the first one. I don't know. We can get all kinds of weird.
Actually, yeah. That actually brings up a good point. Whereas, like, if you leave it undefined, it actually changes the places that you can use that UDF in a way that may be inconsistent across engines, and then leaves a lot to the engine to massage or widen the result.
Yeah, I think so. The end user will even use that because we are thinking about engine, how engine to do the casting, explicit or implicit casting. But from end user perspective, I would assume most of people will love to have a return type so that they know what they are doing.
Yeah. Okay. I think we're all agreed. It's a required return type, no implicit cast.
Cool, cool. So are we okay with this structure? So right now we have the root, which is just a root, a metadata.json file. Then we have this version. In version where basically cover almost everything except the roots. Under the roots, you can have these formats, version ID, something like that. But this version will cover all these overloads, including different signature, different one like signature 1, 2, 3. Then we can also think about put the property under that version, like under each individual signature, right?
Sorry, are you talking about properties or the general structure here? Because I don't see
Property.
properties here.
Yes, I can.
So I like this hierarchy because I think the version used is important for showing what existed when the engine chose a particular version of the a particular signature of the UDF, right? So if you're trying to debug and you're saying like, hey, you know, I did a CTAS and my add function produced doubles, why? Then you might go back and say, oh, okay, well, the long version of this UDF did not, you know, exist at the time or something like that, right? So you're going to want to know what signatures were present at the time you actually tried to resolve the UDF. So I like the, you know, version, high level version with a number of signatures, signatures that exist in parallel, and you can replace or swap them out or whatever you need. And then, you know, they exist as we have been discussing. Properties. What's the purpose of properties?
I think property, there's a few of them, for example, if this function is deterministic or not, is this function secure or not, this property, this kind of property, or any like actual metadata. I'm just a metadata map. Like, for example, if you really wanted to mark and put some label into your UDF, you can kind of do that with the property.
So I definitely buy the argument that a different you know, version of the UDF could be deterministic or non-deterministic, right? Would we necessarily do that with at a signature level? I mean, should the entire UDF be deterministic or non-deterministic? So yeah, I'm just trying to think like what level does this fit into? I know we have
Well, I mean, if you look at other implementations, like, you know, how Hive represented UDFs, and I think Spark does this too. They have a specific feature of is it deterministic or not?
My method on this is it's probably the most compatible way if we put the property on the signature level. In terms of the engine compatible, Snowflakes, Spark, maybe Sparks. So that's because some of the engine, they actually treat a different signature as the independent entity.
Well, hold on just a second. Can we talk about that a little bit? Because like we have this box down at the bottom, which is representation. And I'm not sure what representation is. Like if I think about it, you have versions, and then is your representation the properties associated with it and the signature? Or does that apply for all signatures? Like, what are we?
Representation is what we have been. It's what we did in the view case. So we said you might have a AST, you might have a SQL tied to a dialect, might have SQL tied to another dialect. So it should be representations, and then you might have multiple dialects. The contract for those dialects and representations is that they all produce exactly the same thing no matter which one you choose.
Yeah. Yeah.
Right.
Okay.
So you might have. So this is
didn't know what it meant in the context of this.
This is actually helpful because we know that properties should not be at that level, because all of the representations must be deterministic if the function is deterministic, right? Because they must function exactly the same way.
Yes.
So the question is, across signatures, do we expect all signatures to be deterministic, or can they be non-deterministic selectively?
I feel like that's a bit of a leap to make. And it doesn't really hurt too much to say that for any given signature, you have to declare that it's deterministic or not.
I think I'd be okay with a flag that is like, this is deterministic or not. I don't know about properties, actually.
Yeah, I think the open properties is something we've leaned against doing in a lot of other parts of the spec, when it's something that would be this critical to implementers, right? Like, if we say deterministic here, we actually have to define determinism, and in a way that engines can know they can rely on it or not, which actually may also be more difficult than we want to actually bite off here. Because what does determinism mean in this context? Like, we're an engine sending you a bunch of code that you're going to do something with.
I mean, I think it's pretty clear here that deterministic is, if you run it multiple times with the same input, you get the same output.
And the same input is only the state that is being passed into the UDF.
Yes, only the state that is being passed into the UDF.
I think I can handle that. I worry about other state getting absorbed from like the rest of the context of how a UDF could possibly be executed and doing weird things.
But the determinations that we're making based on determinism is whether or not we can change where this occurs, right? Can I move this node to, before or after a join? Because if I move it and then I need to retry that or anything like that, I can affect the correctness of the query. So I think like if we should start with a very strict definition of determinism.
Yeah. So
sorry.
So I think if I got it right, deterministic could be an explicit property and attached to each individual overload.
I think so, and that fits with the way Spark does it. So Spark, the unbound function, has basically a way to bind to a signature, and then the bound function that is a particular signature has an is deterministic flag. So that would fit with at least the way Spark is doing it currently. And I think we could be more strict that all signatures must be deterministic. But I can think of at least toy cases where that wouldn't be the case. So I can have a rand function, right, that is non-deterministic if you just say, give me a random number between 0 and 100. I can also think of a rand function that is deterministic if you pass in a seed.
So there are a few other properties that we may need to consider, though. So I think the question, going back to what we were started with, was, do we want just a bag of properties, or do we want to call out these specific behaviors, and there's the determinism, there is like documentation, like comment strings. Do we have comment strings? Do we have parameterized comment strings? If somebody does a show functions, like what do we present and where do we encode that? And that would probably have to be at the representation level or signature level or something like that. And then the third one is null handling, how it handles nulls or nans or things like that. I don't know what the specific behaviors are that we would want to include or not, but I was just going through some of the things that get called out by Hive and Spark. They've got some other ones that are a little bit more nuanced. I don't think that they would apply at this level, but I think the question is like, do we just put a bag of properties and then we can evolve and add these as we need to, or do we want to actually call out each one of these specifically?
Also, let's jump to a Moog real quick. You had your hand up.
Oh,
sorry, and we keep jumping in.
You're good. Actually, Dan actually just covered exactly what I wanted to say, which is no, you're fine. So basically, like, what are the idea? Like, what are the things that need to be elevated to like first class fields on the signature versus like do we actually need like a bag of properties, right? I think go through and look at like Hive as an example, or
I prefer determinism secure to be, I think, well-known properties. I think that makes sense, and they should probably be that way, right? To the extent that we can have secure be a thing, right? Like it's tough when you're sending to an untrusted client and saying like, hey, this is secure, but I think that setting that expectation would probably be a field, not a property. However, secure, it seems to me like that it is not tied to signature. Like, why would you have? Oh, some of these versions of this UDF are secure, and some are not. And to Russell's point too, like it's weird if some of these things are deterministic and some are not. So maybe we move that up to a version level. Documentation, however, I think does, like, there are definitely things where you need to say what is going to occur for a particular version based on the signature. So, this is like Java doc for a particular function signature. We don't have all the Java doc for a single function signature, and it gets a little awkward if you do. Granted, like languages like Python, where you use default parameters and things to overload functions, you can do it that way. I would probably say, well, we also have two different versions. We have like a doc on this particular version of a function, docs on the arguments to the function. And also, if you have a doc on one particular signature, do you want that on the others? Because there's also an argument that, like, if you set the documentation for what this thing does, it should only be overridden by a signature. And like the earlier example of an add function, right? Adds the two numbers together. You don't want to specify that for every single overload of your add function.
I think in the add case that makes sense, but aren't there other cases where I have like different parameters and for the same method, and I want to be able to have different docs for each one of those?
Well, I think that's an argument for having a root doc and then signature-based docs, right? Like it just at both levels.
Oh yeah, right.
Or probably more versioned. I don't know.
Yeah. I think there's some requirements from the table spec, like they want a property to be versioned. So we just do it right now for the UDF, and just to save us a few kind of time argument in the future, so that we always get versioned properties.
What is the argument for versioned properties in terms of capabilities? Because I worry that we're going to create a situation in which any little change has large amplification in the metadata, right? So if these things are orthogonal, then properties should not create a new version and copy all the signatures.
I'm not sure I'm worried about that in this case, because I feel like the amount of modifications to this object should be very low. But we
if
would
I
want to know about it.
If I have I mean, so the problem that we see with tables is that we have a lot of snapshots. If we were also creating new snapshots every time, other metadata changed, it would make that problem worse. And here we're saying that you've got, many signatures, like it would not be uncommon to have 3 or 4 signatures with maybe 2 dialect representations of the same thing. Do we really want to duplicate that and create a new version every time a property changes? I would say probably not, unless there's a use case, right? Like, what is the use case for, I need to know what this property was when this version of my function got created? What is the use case for tying those things together?
I mean, for me, it's still the history kind of use case. So, like, if I want to know how a function was run at a certain point in time, I need to know what the properties were at that time, as well as like what the signature was.
Should any of these properties affect how the function runs?
So I don't know if we should have them if they don't.
Well, so what we did on tables and views was that these properties affect things like how we maintain the metadata. So things like how many versions of the function do we keep around before we clear them out, right? So things about this object. But I think in general, what we want is that if there is something that affects how this signature or version or whatever is resolved and how it operates, that should be part of the definition of the signature or version.
Okay, I can buy that. I mean, those are versioned, and then we already are keeping it versioned anyway. So,
and I think the same goes for tables and views, right? Like the view that you select should be self-contained. Like you shouldn't be modifying the contents to return to the engine based on properties of that view. And the same with like a table state. A table state should be entirely contained within a snapshot. So like a version of a function should contain all of the information needed to run that function.
I think that's okay as long as we keep those definitions. I don't think we've done that very well with table, because like metric configuration and things like that, as we've said, like they change the way that data is actually stored and metrics are preserved, and you can't know what the parameters were when a file was made. I bring this up because this has hit us at like a ton, because I have folks internally coming to me and ask me like, I've got a metric file that's missing these things. Does that mean it was broken? Why did it pick these ones at this time? Can we look at the current config and know if they're missing or not? Or, we can't tell the difference between something that's broken and something that was working, because we don't know the configuration under which the file was produced.
Okay.
So that's just my thing. I'm all about keeping those sorts of things versioned and in a different place if we can.
I buy that, but at the same time, I'm thinking that it's more the responsibility of logging what you used than perfect history at the table level.
I think there's like how would we get that logging if it, because in our current setup, a client who writes those files could be a completely different engine. That's the issue, right? Say I'm running. We've had this issue before, right? With like Cloudera 2.7 whatever wrote this Parquet file, and it came out before Bloom filters were implemented or before they were finalized, and someone made a change to the footer after this version came out. So it produces things that are slightly different. And our only way to know that that was actually the case is to look in the metadata of that file and see that Cloudera wrote it at that particular version. And that's real bad, I think, in terms of like damage tracking. Because if that ever got lost, because that file got rewritten, then we have no idea.
In this model, sorry, this is a dumb question. So in this model, how do we keep track of, like, if I wanted to keep track of like which user created a particular signature, user like agent, whatever, like how would I model that in this? Would I
think
We don't
it's
have users.
we don't have the access control any user in the specs, so it's mostly just that the implementers, whoever, like REST catalog, they have only bags or user principal role stuff to apply when they do the entity, like with user passing from the engine sender to the catalog, then the catalog just to resolve them and apply all these access control stuff.
Oh, sorry. So yeah, I mean, like if I wanted to store it as a property, I guess per signature, not like identifying the user, but like how would I store it?
I think if I'm a catalog and I want to track this sort of thing, like what I would do is I then have signature version and I can associate that with some kind of principal or user on my end, on the catalog end.
Yeah.
I again can't track anything in the open properties, so we'll ignore that. But I can tell who made the whole thing, and I can tell for any particular signature version combination exactly who made it.
Okay, sure. Okay, yeah. So we could say it's a catalog side mapping, I guess. Yeah.
I mean, we don't have owners. We don't have people. Don't exist within the Iceberg spec.
Yeah, yeah.
Just the tables.
And I think that's something we want to preserve.
Yes.
I'm trying to think through like signatures and what generates a new version. For tables, it matters a whole lot less. Like for tables, we have this sort of disconnect between the current table schema and the schema at the time of a write. And so we have the schema at the time of a write, and the current table schema sort of floats on top of that. I can change the current table schema several times, and I don't need to like go create new snapshots or anything like that, unless I want to memorialize that, you know, this is the time that it changed. Here, it's plausible that the only change you want to make to a version is to the signature, right? And that could be like, I just want to add comments to, well, first of all, do we support comments in signatures?
So is that doc, or are you saying outside of doc?
I mean, so we could have a signature doc, right? And I think that makes sense. But do you have comments on individual columns within that signature? I mean, it kind of makes sense that you would. So like an exp function with x and y, is that y to the x or x to the y?
I guess the question is, do you need to capture it in the fields, or can we just you write your text in your doc? Like
right, yeah. And but either way, like whether you're changing just the doc attached to a signature or just the comments on signature fields, it seems a little weird that we might have a non-functional signature change, right? Because in Iceberg, it is a new schema to change the comment, right? And you might run several of these in a row. And again, like if we are creating comments on signature 1, creating comments on signature 2, creating comments on signature 3, we're generating new versions every single time and sort of pushing out important information because, you know, if I change 10 columns, maybe that's creating 10 versions and actually like removing or causing the older versions that I actually care about to age off. So that's my remaining like concern with this. I think it's totally fine to say, yes, a column level change or a documentation change generates a new signature definition, generates a new version, you know, that these changes cascade through like that. But we may want to think about how do I make changes to the schemas that we use for signatures independently of the actual you know, versions of the spec, right? Should we have some form of equivalence that ignores documentation so that you can change the documentation on a signature?
What's the major use case we want to change each individual say parameters like column of kind of column in for that signature?
So this is like I develop something, right? Like I independently go and get things working. And then I realize, oh, I need to document this for other people. And so I go through and say like, oh, this is what parameter number 1 is, this is what parameter number 2 is, and like, you know, just go do a whole bunch of things, possibly through my catalog interface. Like at least in Databricks, AI will suggest these things and you just click like, yeah, I want that, I want that, I want that. And so like there are plausible scenarios where we can have like a whole bunch of individual updates to these things. Is that something that we want to account for now? I think that it's good to ask the question now because, you know, that determines the updates that we build into the catalog, right? We could have a replace signature update that, you know, doesn't change the actual versions of the UDF, or and basically like, you know, keeps all of the references valid. Or we could you know, have one that basically goes and creates new versions and updates all those pointers.
Yeah, I think it's kind of MCP style, which we put a lot of description for the parameters with the overall functionality of that signature. My understanding, if we were going to do that, we need at the root level, we create another signature which hold up everything, including the documentation and the definitions. Then within the versions, each overloads were referenced to that one. Is that something we?
Yeah, that's my current understanding, is that we would create, in order to change a column comment or a, you know, signature doc, we would add a new signature because we have these defined as signatures, and then a version has overloads that reference a signature, right? So we would go to the overload that referenced that signature and swap the ID for the new signature.
Yeah, something like that. Then we have ID to reference to that.
Right, and then we've created a new version that references a new signature that has only changed in terms of column docs. Not a big deal. We're just talking about sending, you know, a few K down to the client. But is that worth it, or should we align more closely with the changes that we expect to happen?
I think if updates documentation is kind of frequent operation, I think it's definitely worth it. Which I'm not quite sure. Like for AI, it looks like the people will need more, like especially the machine will need a more description for each like parameters and overall functionality. It is required. But I'm not sure if that's add a lot of value for for human users, like the.
Well, so this just goes back to like there's amplification in what a very simple change ends up resulting in this structure. So, you know, is there a different or better structure that we could use that allows you to, you know, swap out documentation on a particular signature or redefine things within existing versions without necessarily creating new ones?
I think that makes sense to save some, like make that link so that we don't actually splitting everything down to the version, each individual versions. We have just like table, we have the schema versions, and each snapshot will reference to that schema versions, which makes sense to me.
It would be nice if that were floating a little bit more. I'll give that some thought.
We have the Richard time. Thanks everyone for joining this discussion. I think we made a lot of progress here. I tried to get some summaries a little bit later. Anything else you want to before we close this one?
Thanks.
Thank you.
Cool. Thank
See
you.
you next time.